Welcome to our Cosmos studio, where we'll discuss space collisions and how to prevent them. We are fortunate to have Romain, the Chief Executive Officer of Altaria, joining us today.
Yes, hello Xavier.
First, a thesis in the field. It's not common.
Yes, a thesis on plasma physics applied to satellite propulsion. So that was my gateway into space, and since then, indeed, a career in space monitoring and the security.
So first of all, how many, I won't say satellites, but how many things flying that we can detect?
That we can detect, yes. There are nearly 1 million that we can theoretically detect, that we manage to regularly detect and track, and for which we are able to anticipate collisions. There are far fewer. In reality, there are between 30 and 40.
Because 1 million, what does it mean? It means there have been collisions that have made many small pieces.
Or else?
We really sense so many.
Yes, exactly. A space collision. You have to imagine the shock between two solids at hypervelocities. It's 25,000 kilometers per hour between two objects. There are fragments of all sizes that are scattered. There are some big fragments, more intermediate size fragments, and then a myriad of very small objects that are 1 centimeter, a few millimeters, or even below. Objects measuring several millimeters to a few centimeters are very difficult to detect, but can cause significant damage to others. Spacecraft are catastrophic.
And so for there to be so many, that means there has already been several major collisions before between two satellites.
Yes, so it has happened a few times. The main source of space debris throughout history is the fragmentation of reservoirs that have not been passivated at end of life. So at the beginning of the space age, satellites were often lost due to electronics problems or loss of contact, and so the satellites remained in orbit with a large reservoir that was half full of chemical propellants. These are reservoirs that are under pressure, and with the harshness of the space environment, such as the radiation and thermal cycles, these pressurized reservoirs would eventually give way. And because of all the explosives, there are combustible chemical materials inside. It would generate rather catastrophic explosions that would produce hundreds, thousands, tens of thousands of fragments of all sizes.
And which continue today. They do not descend with the time, as we know that satellites
descend over time. Today, practices have evolved a little bit. Since the early 90s, satellite operators are beginning to change the way they work. In low orbit, where the density of debris is the most catastrophic and where there are the most satellites today, operators, before deorbiting their satellite, which is already new, they passivate the tanks. That is to say, they will empty all the fuel into space to avoid it, causing a fragmentation.
One notable collision is when the United States responded to China by shooting down and destroying satellites that passed by using an SM-3 missile fired from an Arleigh Burke-class ship equipped with the Aegis system. What is that? It's hundreds of thousands of additional debris, or was it low enough for it to fall quickly?
So that was an event that was indeed quite low. So a few years later, we don't have too much. We don't really perceive the impact on the populations of debris anymore. The Chinese have conducted tests at a distance of 465 miles. And then we still have dozens of fragments that are tracked. So dozens of fragments that are more than 10 centimeters. That means hundreds, even thousands of fragments, a few centimeters or a few millimeters, that can still be dangerous for space operations.
So now we're talking about debris. Now we're talking about the satellites, about the real thing, about what is operational. How many satellites have we launched since the beginning of the space age?
Since the space age began, I can't recall the exact number, but it's around 12,000 to 13,000 satellites.
It's exponential, or rather it's linear.
The growth is exponential, particularly since the commencement of a Starlink satellite deployment. It's quite spectacular. You really have an exponential increase in the number of satellites for the past 4 years overall. And what's quite funny is that each time there are forecasts of the number of satellites to be deployed, they are wrong, but in a crude way. That is to say, if you look at the 2013 forecast of the number of satellites deployed in orbit in 2020, it's 100 satellites, 120 satellites, whereas in reality, there were on the order of 1,000 in 2020. So there is really an order of magnitude. We have really switched to a larger scale over the past decade, and we continue to break all the predictions that are made. And of course, it's Starlink with Elon Musk who leads this
population, this
acceleration that we observe.
And then if we look at the forecasts that will certainly prove to be false today, we estimate that there will be how many satellites in 2030, for example?
So we estimate that there will be 60,000 satellites in 2030.
Okay, and half of them by Elon Musk.
About half of those will indeed be Starlink satellites. Today, it's 60% of active satellites. By 2030, new large satellite constellations like the Chinese constellation, Kuiper constellation and Iris-Carré, signed last week, are expected to contribute to the orbital population and Europe's space capacity, despite concerns. Will generally be 60,000 satellites.
60,000 satellites at this horizon. Every satellite launch involves checking existing space objects to ensure no collisions will occur with the new satellite for the next decade. Us, or we just shoot somewhat at random?
Space agents have varying practices. What we do in Europe, in general, is the practices of Centre National d'Études Spatiales to make sure that the launch trajectory is compatible with an absence of collision, that each launch will not endanger the manned flights that are in space, so mainly the International Space Station and the Chinese station. But there is no rigorous calculation that is done that would ensure that the trajectory of a rocket does not come into collision with a satellite or debris, even if it was catalogued.
There's still a little hole in the racket seen like that.
There's indeed a little hole in the racket. So the reason, if you talk about it with agency people, is that the dispersion on the objects is so significant on the trajectory of the objects that ultimately, whatever the calculation result, there would be a risk, and it's a risk that we wouldn't be able to reduce, since whatever the trajectory, we would be overall within the uncertainty cones.
Okay, the people who are in the inhabited stations right now, they nonetheless, they need to have a very, very precise follow-up of the arrival of new satellites so they can escape if necessary. It happens from time to time that there are alerts.
Yes, there have been alerts. There have been alerts. There have also been collisions with small fragments that were not catalogued, which impacted the International Space Station with security alerts and the astronauts who were in an evacuation position in the Soyuz vehicle. So that was there about 2 years ago.
Okay, so it continues to happen, to occur.
Absolutely, it's okay.
Right from
More
and more frequently. Your job is to succeed in predicting a possible approach to the benefit of inhabited stations, or are we really on sky surveillance to see spy satellites and all the rest?
We bring understanding of the spatial situation. It's space situational awareness in English. So we detect data, we process this data to then avoid collisions, detect threats, possibly prevent attacks in space. We work on the entire value chain, since we both design and assemble stations, and then we will provide added value services to our clients.
And what do we call threats from space? Because I know that at the time there was an American space station. They even took a weapon on board in case there was an attempt to board. We are not at all anymore in this kind of threat field.
No, so today there's no question of Kalashnikov.
Or anything else.
It's more of a war that's automated, with systems that are partly autonomous, partly guided from the ground. And threats of jamming, threats of espionage, obviously. And maybe one day kinetic type threats, since a certain number of tests have been carried out. So tests, as you mentioned earlier, of missiles that destroy satellites directly, fired from the ground. Tomorrow, why not test from space? It hasn't happened yet, but it could happen. And then threats of boarding, but
Of automated boarding.
which would be carried out in space. And again, a number of tests have already been conducted.
The Chinese have tested, for example, deorbiting by approaching another satellite with objects coming out of the first one. We are still in a very new phase in this field. Following them remains a challenge for you. But what sensors do you have? These radars, is it optical?
We have developed an optical technology for space surveillance with two types of stations, monotelescope stations and multi-telescope stations. And we designed our systems to be able to monitor low orbits, as well as the medium Earth orbit, so where there are global navigation satellites, system satellites, and the geostationary orbit. But our first approach was the low orbits, where the problem is greatest, significant.
What is the order of magnitude? It's 300 kilometers.
Starts at 300 kilometers. And so our systems allow us to cover the entire range of 300 kilometers up to 40,000 kilometers. And perhaps tomorrow, lunar orbit. Also,
So if we're just with optical observations, what is it? It's the size of the table. What are we on? What is the size range for these telescopes?
For the telescopes, listen, you need at least, for a multi-telescope station, you need about a room like the studio. So here, the viewers may not necessarily see the 50 square meters. There you have it, a 50 square meter multi-telescope station, and we...
See, I don't know. This book, we'll see at what distance.
Yes, listen, an Aldoria notebook, we see it about 400 kilometers away.
That's not bad. Here we are focusing on a French national technology developed by your company.
Team, coordinated.
We need multiple stations globally to track it. How does it work? There's a network.
Absolutely, we have a network. We have 5 sites currently, soon 7 sites spread around the world, with single telescope and multi-telescope stations deployed at each of these sites.
And who benefits from this service? Because I don't know, the average person who needs to know if there are any risks of approach or satellites.
Nowadays, an increasing number of state agencies, countries and commercial entities are venturing into space and developing their capabilities in this domain. So we work with these people. We have around 20 clients today, and our main clients are the
Centre National d'Études Spatiales, the agency.
French Space Agency, the European Commission, and then other governmental actors. Europeans?
And then at the level of foreign private companies, do they exist? I don't know. Are they going to launch a new Noryov satellite because it is launched in flocks? Do they appeal to you to see where they can be released with less risk? Or is it really still open bar and they can see any way they want?
Today, there is minimal regulation creating an open bar situation, but also presenting operational challenges. The example of the flocks is interesting, as it's a recurring request from customers who often can't afford to pay, causing frustration for all, a little bit all frustrated. Satellites are launched in batches by multiple operators. One satellite operator has 3 satellites, another has 4, and the last has 12. The launcher's upper stage holds 100 satellites in total, and they are all deployed one after the other. And the problem is that they don't know which satellite belongs to whom at the time of deployment. And so sometimes it takes them several weeks to find out which is their satellite after all. And that poses big problems to be able to establish the trade.
And in the prospects, are there simulations, are there evaluations of the probability of having even more collisions in the coming years in which you could possibly have a utility to avoid them?
So there are 2 parts to the question. So the long-term part, that's a fundamental problem, which is more a problem for agencies, I would say, to model the capacity of the spatial situation and how far we can go in terms of saturation, pollution of orbital space. Today, the Kessler syndrome, so the syndrome which says that from a certain density of objects at a certain altitude, the number of objects will continue to increase simply because of the
collisions, that's it.
Meaning that the effect of the collisions is more significant than the moderating effect of atmospheric drag or other natural phenomena. This Kessler syndrome, it's already reached around 800 kilometers, meaning that even if we stop launching satellites at 800 kilometers in 100 years, there will be more objects in orbit than today.
There's no way to clean them up. There's not a big fishing net.
Unless we clean them, unless we send a big fishing net, or if we can find an effective way to clean them. So there are some of our clients who are working on these topics to be able to recover debris and deorbit them.
Okay, so there are still objectives for cleaning up space and not just monitoring, so we can add even more.
Yes, of course. We allow for the cleaning of space to be possible thanks to a precise mapping of objects and the risks.
A little word about Aldoria. How many are you? Where are you based?
And we are soon going to be 50 people. We are based in Paris, Toulouse, and Austin, Texas. We also have a small branch in Brussels. And there you have it. We specialize in that field, space surveillance and space security. So we are essentially experts, engineers, people who either work in space agencies, who have worked in major industrial companies, who have worked in academia. And so for the past 7 years, one of my big challenges has been to build a team that will be able to solve this challenge.
So these are mainly European teams with possibly a little bit of Americans. However, we are dealing with a sovereign technology and company, or there are still foreign partnerships that are today we cannot do without.
One of the reasons for Aldoria's existence is indeed to provide a solution for European sovereignty in this field. Since today it is clear that Europe largely depends on American data for its understanding of the space situation. I recently spoke with a colleague who mentioned that he had seen unexplained things in space from his garden in Normandy, and that the French authorities are not necessarily able to see it, to identify it perfectly independently.
It can be UFOs, it can be satellites revolving around each other.
There are indeed spacecrafts that have very significant mobility capabilities. They can change orbit quickly, they can perform maneuvers, go from 400 kilometers to much higher orbits, re-enter the atmosphere. So the Americans and the Chinese have these capabilities. And in France and Europe, we are not able to follow what these objects are doing. We do not have that capability. So with Aldoria, we are not going to solve the problem of European space security alone, but we are bringing a solution element that is very important, very credible with optical technology.
And in terms of sovereignty, can we also
know where...
And when do the spy satellites of those who would try to spy on a spy?
Example. Absolutely. One of the great challenges, one of the great shifts at the strategic level has been the integration of satellites into operational theaters. So the integration of satellites at the tactical level, where during the Cold War satellites were really at the strategic level, they were used for deterrence, but they were not necessarily essential for some
military operations.
Specific.
We see an acceleration with Ukraine, yet another
time there.
We are on a reactivity that is almost within the hour that follows for photo satellites. They strike rapidly there, including with drones. So that's a big novelty. You're hiring?
Absolutely, we are hiring. We are always hiring. We are in a phase of expansion. We raised a little over 10 million euros last year. We have large institutional clients who follow us and adopt our solutions. We are developing this market and trying to develop a leadership of Europe in this area.
Well, Roman, thank you very much. Thank you.
A lot.
I wish you success. Anyway, there is a need that will make it grow, especially a lot of success.
Thank you very much, Xavier.
We hope you enjoyed it, and we'll see you soon at the RN Cosmos studio.